And I'm Greta.
And I'm Sunita.
Table of contents. What's our topic? So our topic is we analyze city-level high school poverty rates, state-level youth depression statistics, and demographic-based disability estimates to uncover patterns of disparity. Through statistical analysis and data visualization, we investigated how demographic factors correlate with social outcomes. Our findings highlight key relationships and suggest which populations may face compounded disadvantages.
Yeah, so our point of interest was that we just wanted to work with something that had mental health but also had pretty simple, like a simple topic so that we could do something really interesting with it. And the CSV just had a lot of entries, I had a wide variety of problems. The HTML file was really concise and it just gave us a good overall view of what we were trying to work with. And the JSON file was a CDC survey, which meant it was pretty dependable and it also related to our other data sets.
So the expectations were that we expected us to see a positive and strong relationship between poverty, disabilities, and disability rates.
And how we found our data sets, we found the CSV using one of the links that were provided in the phase 1 document, and this actually helped us find our topic because the data set was so interesting. It had really interesting characteristics, and the characteristics were just schools, latitude coordinates, longitude coordinates, IPR estimates, which is income to poverty ratio.
For finding the HTML, we originally had another file, but we were unable to extract it successfully with Selenium, so we ended up looking more into like Google searches, and we eventually found this data set. And then for finding our API, we first began by finding a website that had multiple data sets in it and found a way to extract the information. And we found other APIs, but they didn't load or they didn't have enough information, so this eventually worked out for us.
So our data cleaning process, these are some screenshots that we'll come back to later. So for our CSV, we took the columns that we wanted, which was just the latitude, the longitude, the high school name, and the standard deviation, and we used the latitude and longitude to reverse geocode the coordinates, and we used this API called OpenCage API, and we only took high schools, which made it 10,000 requests, but OpenCage is only 2,000 requests per day. So to make it easier and also more ethical, we binned every 8 lines by latitude and longitude, and that helped because the CSV was already organized by latitude and longitude, so the first 8 lines, or the first 8 lines that are high schools, were pretty close to each other. And then we just sorted the final by the most affluent states.
So we accessed the HTML and web source to get the table with the link with the beautiful soup. And so we either completely got rid of any rows that were blank or replaced it with the NA for rows with headers, which would allow for clarity.
And then we accessed the API and we just turned it into a dictionary, and we passed through each entry, taking the area, the confidence interval, and the percent, and the demographics, and we just replaced suppressed and total with NA. Suppressed we thought was just hidden for privacy reasons, and total we couldn't really figure out, but we just made it NA. And this is our code. This is the CSV, and it just shows us using the high schools, and then this whole if statement is us saying if the length of a list is 8, which means if we have 8 lines in our list, then we make the request, and this is us finding the average longitude, making the request, and then finding the city and the state, and we're only taking it if it's not none, because sometimes the API couldn't find the state or the city.
And then for this one, we can see the headers being named. After we extracted the HTML file with Beautiful Soup, we renamed the headers, and then we extracted and removed any rows that were empty and only saved the rows that have at least one non-empty value in it. We also added the NAs in it just to allow for better running of the code. And then for the API, we extracted again, we got the API, and then we removed any inconsistencies in the data and iterated through all the dictionary entries, wrote the list to a CSV file.
And then this is the data insights and visualizations. So for the first insight, it was do states with higher city level poverty rates also report high youth depression rates. And we just made a data frame for each CSV. We grouped each one by state, and then we merged them. And so it gave us just the state, the average IPR estimate, and depression, and then we imported Pearson R function from Skippy Stats to find our correlation in our p-value, and our p-value is basically a number between 0 and 1 that shows us how likely it is to not have been random chance. So below 0.05 means it's not likely to have been random chance, and it was statistically significant. And then for the second one, we just found which states have the highest variation in state level poverty, which just means we took the CSV, made it into a data frame, grouped them by state, and found the mean of the grouping and the standard deviation, and reached to the top 5.
For the third one, we basically just got the disability rates for the male, female, and the average one. So it's 13.0, 12.2, and 12.6 respectively. And for the fourth insight, we aligned the poverty bins with the federal income thresholds for both the individual and family, and found students with disabilities are more concentrated in lower income ranges.
And then the last one was we were just finding if there's a correlation between the 10 poorest states and a demographic that has the highest youth depression rates. And for that, we just made a data frame for each CSV, the CSV and the API, and then we grouped both of them by state one of them by state and the other one by the most depressed demographic in each state. Then we merged them on the state, and we found the 10 poorest states based on the inverted IPR estimate, which we just subtracted from 1,000, which means the higher it is, the more poverty they're in. And then we used Chi2 contingency from Skippy sets to find the correlation, and ours was not statistically significant. And so the significance of this, for the first one, it just shows us how the two demographics might be influencing each other. And because it was a correlation of -4, it's negative weak, which was kind of surprising because you would think lower depression means higher income, but it doesn't, so we think there might be a confounding variable, but ours was statistically significant. And then for 2, it just allowed us to see the variation, and it can kind of help us make definite claims and just say like the poverty is very displaced in that state.
For the third one, it just highlights the subtle but prevalent gender disparities in disability prevalence. And for the fourth one, it shows that the disability prevalence and in the highest and lowest poverty brackets, it shows that the students with disabilities are more concentrated in lower income ranges.
And for the fifth one, it didn't give us anything significant data-wise, but it was just interesting to see like how women were the most depressed in the poorest states, and that was just a cool thing to see. And so this is our code. We'll just run through really quick. You can just see us importing the functions here. You can see us having the individual income here, and then us again not importing, but using the chi-square test of independence here. And then this is just this is from Insight 1. You can kind of see the relationship, how it's not as strong as you would expect, but you can still see it like descending, which I think is pretty interesting.
This is a visualization from Insight 4. The line graph shows the clear trend. It's descending, especially for the with disability group. So it shows that the disability group is concentrated in the lower income ranges. And for the third visualization, it's from Insight 2. So it just in general shows the average adult depression rates across the U.S. states. The darker states higher.
And this is just us explaining the visualizations and then overall results. Skippy stats is a new method that we learned how to use. We brought our Pearson R and Chi2 contingency from it. And Chi2 contingency took a frequency table, which you can use making pd.crosstab, and Pearson R takes 2 arrays, but we just used 2 columns from our data frame. And bidding and reverse geocoding was just a new method that we used to to classify information, and bidding was interesting for us to figure out, as well as like using an API in our downloaded data set.
So the greatest challenges was one, finding unique insights. We were just hoping not to find too many repetitive ones, so we were trying to look for a lot of unique insights, especially since a lot of the variables overlap, like poverty and mental health.
And then finding the large data set, it was just hard because there were so many entries, we couldn't make that many requests. And so we tried to use this Python module called GeoPy to reverse geocode, but it was just really slow, and it was like 1 request per second. So it didn't prove to be as efficient.
And finding consistencies, a lot of our data sets were very well organized, so we had to really look through the data sets to find inconsistencies.
And then our results overall matched our expectations, but there were some really interesting correlations we found, and we were just surprised at how like stuff ended up being significant, and we were just able to do really interesting things with our data.
This is just our documentation and Python notebook link, and thank you.
Thank you.